All right, we're back. We're on page 175, and we are dealing with hyperbolas. And so I have put a joke. The absolute greatest examples ever. This is using hyperbole, which is like hyperbola, but wrong. If you're not sure what hyperbole is yet, I don't know. Look it up. But all right, let's see if we can do the problem. So write the standard equation, and maybe write everything, right? Maybe always write everything, unless it's a quiz or a test where time is a factor. Write the standard equation of the hyperbola with a center at 3, -4, one vertex at 0, -4, and one focus at 9, -4. Now, let me be honest with you. The thing that is the hardest for me about these is that I confuse horizontal and vertical lines, and I'm not super great at that. So what I'm going to do is I'm first just going to make like kind of a set of axes. So I'm using like this grayish color because it's not the real axes. What I'm going to do is I'm going to like use the intersection of these as the center, right? So that's 3, -4. That's my center. 0, -4. So 0, -4 has to be to the left, right? So that's going to be here. This is going to be a vertex, and that's at 0, -4, which means the distance from the center to a vertex is a, so I now know that a is equal to 3. And then a focus is at 9, -4. So 9, -4 would actually, based on what I've drawn, be like probably over here. So I know, because that's that's a focus. That means that I know what C is. So I'm going to say C is the distance from here to here, and that distance is 6. So C is 6. Then I know that A squared plus B squared equals C squared. So 9 plus B squared is 36. So B squared is going to be 27. And I actually need B squared to write the equation, so I'm going to kind of like leave it at that. But it just means that I know that, B is radical 27, so we'll have a co-vertex here. And if I were going to draw it, I would go through the vertices. I would not go through the foci, but I'm not going to draw it because it doesn't ask me to do that. Sometimes you're asked to draw. I don't know, just practice graphing them. Practice graphing in general. Graphing is not my favorite thing. If you've watched enough of these videos, you know that graphing is probably not my favorite thing. So 7 things here. 1, the equation. So vertices on a horizontal line, which means that it's eating a horizontal line, x comes first. So it's going to be x minus 3 squared minus y plus 4 squared equals 1 over some stuff, right? So we said that a is 3, a always goes first, so that's 9. So think about it, you're at 3 and you can go 3 in either direction to get to your vertices. And then it's going to be b squared, so that's 27. So you are at -4 in the y, and you can go radical 27 this way, radical 27 this way, and then equals 1. 2, the center, which was given, but we listed anyway. 3, -4. Imagine getting that wrong. I've done it. If there's a mistake to be made, I've probably made it. 3 plus or minus 3, comma -4. And I survived. And am I stronger for it? I don't know. But I did survive. And that's what counts. Plus or minus radical 27. Getting them done. 5 is going to be foci. Like really just memorizing these things that you need is like a huge advantage. Plus or minus 6, comma -4. Eccentricity, which is going to be C over A, so 6 over 3. Oh, 2. That's nice. It's got a nice eccentricity. And then we also need the asymptotes, which I'm going to put over here, I guess, because space. So the asymptotes. So for me, for the asymptotes, I change this into a 0, which effectively just changes this into the equal sign. I'm bring 27 across. 27 over 9 is 3. Then square root that. So I'm going to get square plus or minus. So let's say y plus 4 equals plus or minus the square root of 3, and then x minus 3. So that's pretty weird, but it sort of it makes sense, right? Because this is radical 27. So you go up radical 27, you go over 3. So radical 27 over 3, radical 27 is 3 root 3, radical 3 root 3 over 3 is just root 3. So the slope of one of the asymptotes is root 3, so the other one will be negative root 3 plus or minus root 3. So I think we got it. Should we do another one while we're here? I don't know, probably. Right, the standard form. All right, I'm gonna do the same thing again, right? I'm gonna go with some gray axes to like help me out. This, by the way, is like a new innovation. I did not always do this. In fact, I don't think I've ever done it prior to now, but I was getting very nervous because I do screw up horizontal and vertical, and I'm tired of doing that. So the vertices are negative 18, that's a vertical line, right? So negative 18, 2. So I'm gonna say, I'll put this down here at negative 18, 2. I'll put this up here at negative 18, 20, and those are vertices. So now I know the center, right? The center is the midpoint of this. So 20 plus 2 is 22, divided by 2 is 11. So this point, the center, is negative 18, 11. Quick check. From here to here is 9. From here to here is 9, so probably right. And that's the value of A. So I'm going to say A, because it's from the center to a vertex, A is 9. We also figured out the center was negative 18, 11. I'm not going to write that yet, even though we need it. And then covertex, negative 9, 11. So where's negative 9? Negative 9 is this way, which is like a little confusing to me. So if you're me, that's confusing, maybe not to you. Covertex rather. And that tells me, so the distance from here to here is 9. So B is also 9. That's like, you're going to get a really pleasing hyperbola to look at because A and B are equal. So it's like got that square asymptote box, and then that's like just the best looking that you can get, I think. It's like those are good. Then the Pythagorean triples give you nice looking ones. And then you get those radicals, and like, I don't know, there's nothing wrong with them, but like, you know what I'm saying? Because I don't, but maybe you do. C squared is A squared plus B squared. So C squared in this case is 18. So C is radical 18, if you need. Or 3 root 2, because I think we're going to be able to simplify. Is that right? Because A is 9. I was thinking like A was 3 because 9, I don't know. All right, let's write our things. 1, equation. 2, center. I'm just going to list them. 3, vertices. You get in the zone, and then it's like, it's underrated, man. Like knowing what you're doing is super underrated. When you watch somebody else like work on these, and you're like, how are they going so fast? It's like they know what they're doing. And then asymptotes. All right. So what are we doing first? I mean, the center we found was negative 18, 11. The equation, so vertical, because the vertices are on a vertical line, which means that y comes first. Don't mess up h and k. So it's going to be y goes with the y coordinate of the center. X goes with the x coordinate of the center. Equals 1. And then A always goes first. Actually, A and B are equal, so it doesn't really matter. But A always goes first, B always goes second. Vertices. All right, so you're negative 18, and then you go up and down. So comma 11 plus or minus 3. Covertices, you're at negative 18, and you can go plus or minus 3. Wait, what? A is 9. I knew I messed myself up by like thinking that through. Here we go. These are 81. Right? A squared. B squared. This is plus 9, plus or minus 9. Mistakes were made. Okay, so vertices and foci both going this way in this case. So it's going to be negative 18, comma 11 plus or minus radical 18. Simplified if you want, 3 root 2, not a problem. Eccentricity is C over A. So it's 3 root 2 over 9, so it's root 2 over 3 if you want, or I'm happy with root 18 over 9. Like that does not really bother me, but I know it bothers some people. So in which case, simplify. Here you get some nice asymptotes, right? Because change this to a 0, which means this becomes your equal sign. Bring your 81 across. 81 over 81 is just 1. So we're going to get y minus 11 equals plus minus x minus, nope, plus 18. Unless I had it wrong. Yeah, there we go. Okay, so I'm definitely going to stop here and come back in the next one and do more of these. Oh my God, this page has so many problems on it. Come back in the next one and do more problems, mostly for time, out of consideration for your time. All right, so I'm going to stop here and I will see you in the next one.